Okay guys, let's look at problem 2. Let's use the unit circle to evaluate the 6 trig functions of theta equals 4 pi. Let's draw our initial side. And then remember we're moving in the positive direction there. 2 pi. Another complete revolution, 4 pi. Okay. So 4 pi, if I'm on the unit circle, this location here, well, that's 1 on x and 0 on y. Okay. And for me, I just immediately say, oh, that's a quadrantal angle. And remember, x corresponds to cosine, y corresponds to sine on the unit circle. Okay, so I can quickly then begin. Well, sine of theta, well, sine of 4 pi here, let's use 4 pi. Well, that's going to be 0 over your radius of 1, which is 0. And cosine of 4 pi, which is 1 over your radius of 1, 1. Tangent, sine over cosine, right? Sine is 0, cosine is 1, 0 over 1 is 0. Or y over x you could use too. Okay, cosecant. Well, cosecant of 4 pi is just sine flipped over. So instead of 0 over 1, 1 over 0. 1 over 0 is undefined. Secant of 4 pi. Well, that's just cosine flipped over, so 1 over 1 is still 1. And the cotangent of 4 pi, again, is just tangent flipped over, 1 over 0, again, undefined. Okay, so and remember your definitions are always in the book if you forget, which is sine of, say, an angle, x over r, y over r, cosine is x over r. And we're able to simplify these as we go because our radius is always 1 with the unit circle. Okay? And everything begins by knowing sine and cosine, and from there everything should be easy to construct if you've got those two. Or easier to construct. Okay. Thank you. Okay guys, let's continue here on number 3 and find the reference angle for each angle. Okay, remember, theta equals 250. Always start here with your initial ray, the positive x-axis. And if it's positive, we're going to move in that counterclockwise direction. 180. And then I know 270 is the next axis, so I'm pretty close to it, but I'm not all the way there. And again, that's theta. Well, how do I determine here theta prime? Again, which is my shortest acute angle to the x-axis. Well, in this case, I can do 250 minus that 180. Remember that is a semicircle. And that'll give me what's left, which is theta prime. 70 degrees. So my theta prime here is 70 degrees, and that's called my reference angle. And that's, again, from your shortest acute angle up or down to the x-axis, depending on where you are. Okay, how about negative 7 pi thirds? Initial side. Well, I think, first of all, I know that 2 pi, or in this case, negative 2 pi, is a complete revolution. So, if I know that a complete revolution is 6 pi thirds, or 2 pi, right? That's the same as 2 pi if I reduce it. Well, though, when I go to move I know that I have how much more besides the, say if I moved that negative 6 pi thirds, how many more pi thirds do I have to get to negative 7 pi thirds? Well, one more pi thirds. And remember, if pi is a semicircle of 180, that's dividing pi into 3 parts. Okay, and there's my terminal side. Okay, so notice for negative, we move in the negative direction. And I could have also have done this as 6 pi thirds minus 7 pi thirds, which leaves me with negative pi thirds. But again, for our reference angle theta prime, we don't need the negative. We just know that it's pi thirds. This distance from here, from the x-axis, down to our terminal side there. Okay, and remember pi thirds is how much? Well, it's a 60 degree. Okay, we can always go between the two of them by converting. Okay, so our reference angle here, theta prime, is pi thirds from the terminal side up to the x-axis. And notice on this one I moved in the negative direction, which was clockwise. I moved a complete revolution here. And then whatever I had left to move was this. And so I know that's how much was left. And that's also what's left to the x-axis. So that's my reference angle. Pi thirds or 60 degrees. Okay. Okay, guys, let's look at problem 4 here. Evaluating the following without using a calculator. Okay, we're on the unit circle here. And we've got the tangent of negative 315. So this begins again like the last ones did by finding my reference angle. Initial side, move your negative 270, and then I know I get back here. And again, you could do 360 minus 315, which leaves you with 45. So I know my theta prime here is 45 degrees. Okay, and then I want to construct essentially the right angle down here. And I know that that's 1, so this location here on the unit circle, well, each side will be root 2 over 2. Root 2 over 2. And since I'm in the positive first quadrant where x is positive and y is positive, that location there up here on the unit circle, say if I was on the unit circle here, that location up there is, well, root 2 root 2 over 2. Okay, so, and remember, these are our x and our y, and our cosine and our sine. All right, so tangent of 315 equals sine over cosine. Root 2 over 2 over root 2 over 2. And when I invert and multiply, what happens to everything? Well, it all cancels. Positive 1. Okay, so what did we do? Well, we drew our initial side. We moved clockwise in the negative direction. We drew then our reference angle, the remaining amount to, say, the x-axis, the shortest acute angle to the x-axis. Then I drew that location on my unit circle. And I knew it was a 45, so dealing with the 45, both the sides are equal. And with the radius of 1, each of the sides is root 2 over 2. And then I labeled them. I labeled that location in space on the unit circle, x comma y, cosine comma sine, and then I did tangent, which is y over x or sine over cosine, and that becomes 1. Okay, let me erase. Let's do the next. Okay, cosecant of 13 pi thirds. Well, I know that 6 pi thirds is a complete revolution. Well, 12 pi thirds would be 2 complete revolutions. So, I know I've got at least 2 complete revolutions. Initial sign. And it's positive, so we're going to go in the positive direction. So let's start here. Counterclockwise. 2 pi. 4 pi, or 12 pi thirds. Well, what's 13 pi thirds minus 12 pi thirds? Well, pi thirds. So I have pi thirds left to move, which is, again, a 60, if that helps, okay? So I'm going to go another pi thirds. Doop. And then really this is going to be, say, a location. And I'm going to draw this line down at right angle to the x-axis there. Okay. So theta prime was pi thirds, or 60 degrees. And I'm just going to kind of dot this on a little unit circle here with a radius of 1. Okay, so if I know I've got a pi thirds here in the first quadrant, which is a 60, then I know that this is my long side, root 3 over 2, and this is my short side, 1/2. Well, we're in positive territory, so this location will be x comma y, 1/2, comma, root 3 over 2. Okay. And they want us to find cosecant. Well, we're not far off. And then I say, oh, that's x, that's y, that's cosine, that's sine. Well, so then the sine of 13 pi thirds, which is the same as the sine of pi thirds, or reference angle, okay, well, is root 3 over 2. Well, what's cosecant then of 13 pi thirds? Well, cosecant of 13 pi thirds is just sine done what? Flipped over. 2 over root 3. Then I have to do what? Rationalize. So 2 root 3 over 3. Okay, so the cosecant of 13 pi thirds, which is coterminal with the cosecant, say, of pi thirds, is 2 root 3 over 3. That's my answer. Box it in. Okay.